Hi guys, this is Jonathan Lambert with Maths and Stats, and in this short video, another video in our series of videos dealing with correlation analysis, and in particular non-parametric correlation analysis, we're going to concentrate on the calculation of the correlation between two variables, where both variables are measured on a nominal scale of measurement. So both variables are measured on a nominal scale of measurement. But more importantly, these two variables, they're not dichotomous, okay? They have more than two levels of measurement. So actually, technically, we should really define them to be have a multichotomy. Yeah, so these are there's a multichotomy, okay, and they're multichotomous, okay, basically. So multichotomy really should be there, right? Okay. So what we're going to do is basically it's the correlation between two nominal variables where each variable has more than two levels of measurement. In this particular instance, the correlation coefficient is known as Cramer's V. So it's Cramer's V correlation coefficient, and the formula for Cramer's V, sometimes labeled as C or V, maybe we'll just call it a C, is equal to the ratio of the choice squared in relation to the contingency table associated with two variables, the ratio of the choice squared to the total sample size, the total number of observations, plus the choice squared value, and it's that raised to the power of a half, or more importantly, it's the square root of that particular value there. So this is the formula for calculating the correlation coefficient between two nominal variables where each variable has more than two levels of measurements associated with them. So let's have a look at an example. Okay, so let's say that we measured two variables. Okay, and the first variable was probably called let's say job role. Okay, job role. Okay, and the second variable is, let's say, car class, the type of car that you drive. Let's say, just say for argument's sake. So we measure two variables. The job role, let's say we have got three categories. You're either an executive. Okay, let's say the first person was measured, they were an executive, they drove a Mercedes, let's just call that Merc. The next person was an executive. They also drove a Merc. Let's say the next person was, let's say, middle manager. Let's just say manager, okay? And let's say they drove a BMW. The next person was a manager, and they drove also a BMW. Let's say the next person was a manager, and they drove, let's say, a Merc. And let's say the next person was an operative, just a floor operative. And let's say they drove a Volkswagen, okay? And so on and so forth. But the important thing here is that what we can actually see in this particular instance is that we've got three levels of measurement associated with job role. You're either an executive, you're a manager, or you're an operative. And in relation to the class of car that them particular individuals drive, we've only got three levels. In this case, we could have more types of cars, and we could have more types of roles, but the most important thing in this situation is that we've got more than two levels of measurement associated with the nominal variable in both cases. In this case, we have Merc, BMW, and Mercedes. So in SPSS, or let's say as you capture your data, you might capture it in this particular fashion where we have the variable views here in relation to all the observations on each variable, but more importantly that these are paired observations, individual participants are across the particular roles. So what we really want to do is we want to convert this particular table into an observed frequency table. So let's say we have an observed frequency table. Because really what we need to do is we need to calculate the chi-squared statistic, yeah, for the observed frequencies and compare them observed frequencies against what we'd expect to happen if if the variables were, let's say, independent of each other, if that makes sense. So our observed frequencies, so let's just list, we have exec, we have mana for manager, and we have oper for operative. And let's say for argument's sake, going across here, we have Merc for the type of car, we have BMW, and let's say we have Volkswagen. So what we have is we have this observed frequency table, and what we're going to do is we're just going to fill it up with frequencies. Okay, so let's say, for example, that we had, let's say, 20 executives driving Mercs, let's say 10 driving BMWs, 5 driving Volkswagens. Let's say we had 10 managers. Let's say we had 7 driving Volkswagens and 3 driving Mercedes. Let's say the operatives, one operative drove a Mercedes. Let's say for argument's sake, let's say 9 drove a BMW, and let's say 15 drove a Volkswagen. Now you see, I'm sort of staging this. See, I'm staging this to sort of to show you that there is a relationship between the the job role and also the car of class that you drive. Okay? So what we'd like to do is we'd like to test this. We'd like to calculate the chi-squared, let's say, test statistic for this particular contingency table. So what we need to do is these are our observed frequencies. So these are our observed frequencies. So what we need to do is we need to build our expected frequencies. And maybe what I'll do is I'll just give you the formula for the chi-squared, test statistic. So when we have a look at the chi-squared test statistic, chi-squared is effectively equal to the square. It's equal to the square of the observed frequencies minus the expected frequencies squared. And that's all relative to the expected frequencies. And what it is over all particular, let's say, classes, we sum up this. So what we need to do is we need to build an expected frequency table. But the important thing is that the expected frequencies, the FEs, are simply equal to, so if you want to calculate the expected frequencies, it's the row total times the column total divided by the total number of observations divided by the total number of observations that we have. So in this situation, let's just, from our observed frequencies, let's calculate our marginal total. So for executives, you can see we have 20, 30, we have 35 executives. Managers, we've got 3, 13, and